Very great. Thanks, Venkatesh. Marian, can you forward a couple slides here?
Yeah.
Sounds great. All right, so we'll be talking about data discovery over wide spatiotemporal scales for this first use case. Next slide, please. The first data discovery use case that we've talked about using is the lower Mississippi River. This is a site that is currently, the main reason for choosing it is it has a bunch of different types of data that we know of and we have in hand, so we can sort of use it as this pilot. It stretches essentially from Vicksburg down to Natchez, Mississippi. It has a series of cross sections that are made there. It has 2 gauges in this reach, 2 USGS and Army Corps gauges. There's a whole series of multi-beam echo sounding data. There's also a whole bunch of both airborne and satellite imagery for that site, particularly for Yucatan Lake, which I'll show you here in a second. So the thought is, can you go to the next slide, please? To try to first off focus on some of the imagery data in combination with the DEM data. So at this site, we have LiDAR DEMs for both banks. In some of the sites, there are 3 stacks of those, so 3 different time periods showing some of the change. This is the Yucatan Lake area. There's also a whole bunch of optical imagery, which we can use to then intersect with the LiDAR DEMs. There's a bunch of radar imagery that's both airborne and also satellite-based that we just happen to have. There's no reason otherwise to choose that. It goes everywhere. There's a number of satellite green LiDAR tracks over that site, which is from the ISET-2 satellite. We also have MODIS inundation records for there. And we have a series of field data in addition to, so we have point-based data, cross-section data, and also multi-beam echo sounding data. And so the idea here really around this data discovery is to easily get all this data into one particular format and be able to look through it, probably using a hydrograph as sort of a filter. We've talked about sort of different things, but something along those lines. I think you can probably see where that's going. All right, back to you, Marian.
Yeah, I will continue the data discovery use cases with the on-ground based collected data. And I show you here the first actually products of our project, which are already in the connected to databases and so on. The location of this data discovery is focused on ADCP measurements, and we start from the watershed, as was mentioned before. We look at the river segment of interest for our project. Then we look further into the reach, where specifically we search for data. That data appears like it's shown in this graph, and then the data points are converted actually and displayed as transect of ADCP. And with some character metadata, just to inform you about what's there, and possibilities to download that transect as raw files. And then we are working right now on developing from transects cross-section with RIMORPHIS tools. Another case, another case on ADCP focused is another type of measurements, zigzags across a stream reach. And we display the path of the ADCP measurements, and then tools are available for creating bathymetric maps, as many of us saw in publication and so on. We plan to bring all these tools in one place. So that would be a case, and a use case. Use case number 2 is reach scale analysis, which will benefit considerably from our developments if we will be successful to do all what we promise. And we make use here of a very rich data set collected by ERDIC, US Corps at ERDIC. along Mississippi, where they have transects with ATCP, fixed point measurements with ADCP, suspended sediment with conventional tools, with optical tools, and also bed material sampling, and something which is kind of particular to them, and we build on that information, repeated MBS scannings in a given reach to inform on bed load transport rates. And with such an abundance of data, you can do a lot of things, but first of all, to bring them at the reach, at your mouse, and to be able to look at the data in various ways. Like here, we combine MBS and ADCP data. We look in the cross-sectional secondary flow if that's what is needed, and all this will be based on, simple dialogue between you and the platform to be able to pull that information from the existing data. Another example, I would like to bring here the repeated MBS surveys from the same data set. On this area, 4 repeated surveys were obtained, and as you see in this animation, those 4 can be visualized. You get a sense of what dynamics is on the bed form. And then we apply PIV on these repeated images to put bed form velocity fields, and with analytical equations, we can calculate bed load transport rate remotely, non-intrusively, and we have a package of software already working called AMV to do all these things. Another example of what our platform is supposed to do is visualization, quantification of suspended sediment, measurements from the same data sets, suspended sediment from the backscattering of the ADCP, calibration with list, which allows you then to do visualization mapping of the suspended sediment in the measurement location. So these are some examples which we wanted to give you perspective on. Venkatesh?
Yeah, please, next slide. So in terms of network scale analysis, as I mentioned before, we have developed some tools for creating river bathymetry. But just before we get even bathymetry, we want to make sure that the hydrography that we have is good and it matches with the data we have. So what you see on this slide are sort of 4 quadrants. So on the top left, we have been developing tools to correct the center line. So we have NHD, and sometimes it doesn't align with, let's say, your recent LiDAR data set. So how do you correct that NHD line to go through the center of the river? So we are developing tools to correct that center line and get a really nice center line gap that will go through the LiDAR data set, for example. So we are developing tools for that. So on the top left, you see a single reach, and on the top right, you see how it will look at the confluence. So how the current data set may look when you get it from some of these public domain resources, and how you can correct that and make it smooth and so on. We are also developing tools to delineate banks from LiDAR data or any other data set. So if you have a good data set, we are working on tools to get banks. And once you have the center line and banks, and if you have some cross sections, and if not, you can also create some synthetic cross section. And then you can create a detailed 3-dimensional bathymetry for the entire string network. So what you see on the bottom right is a LiDAR data set on the left of these 3 figures, and on the right here, what you see is a nice 3-dimensional bathymetry integrated into your DEM or LiDAR data set. So next slide, please. And the goal of this will be to create a three-dimensional bathymetry dataset that is integrated with the DEM, and on top of which you can do detailed large-scale hydrodynamic modeling. So what you see here is an animation for Wabash Basin. So we have a hydrologic model that does this right now. So we are incorporating detailed three-dimensional bathymetry to go with that model, so you get accurate results of your flood inundation and map the extent and the depth. So we are developing tools so people can create detailed river hydrography and bathymetry that can be used at this scale or even larger scale. So next slide.
Amanda?
So this is the fourth use case for the RIMORPHIS project. Can you go to the next slide, please? This use case will focus on forecasting long-term changes in channel morphology. The case study will demonstrate how the data available in the RIMORPHIS platform can be used for the required inputs for hydrodynamic and sediment transport modeling, and with really a specific focus on evaluating the range of potential long-term river morphology conditions. For this study, we plan to use a next generation modeling tool. It's called Future River Analysis and Management Evaluation Tool. The acronym is FRAME. This model is in its early stages early stages of application, and the use case provides a really great opportunity to showcase the value of the RIMORPHIS data to support advancing these types of innovative modeling tools. The FRAME tool is uncertainty bounded and flexible to explore a range of possible future scenarios. As we know, some of the model inputs have notable uncertainty, like the bed and bank material and the exact future sequence of river flows. So in the model, if we feed these variable inputs into the model, the results will provide a range of output conditions, possible output conditions. One of the things, for example, if you're interested in looking at the elevation of the channel thalweg after modeling 50 years at a certain location is an example of one of the things that we could look at. So next slide, please. The tool is a hybrid tool in that it incorporates the traditional process-based hydraulic and sediment transport models with a set of rules for how the channel responds to imbalances in sediment transport rates. And finally, the tool can provide a variety of indicators for different channel flow conditions, different channel conditions such as reach habitat or environmental flows. This slide shows an example scenario of forecasting of the Mississippi River 50 years into the future. And so for this study, RIMORPHIS will provide access to critical data necessary for these types of forecasting studies, which can reveal the long-term impacts of changing hydroclimate, changing river management, changing sediment inputs, and can also integrate the inherent uncertainty in river processes. And I think that's our last use case. And so I think this wraps up this portion of the presentation.